Fundamentals of the nervous system. The basic functions of the nervous system include sensory input. You have a variety of sensory organs that will detect changes in your internal and external environment. Your eyes, for example, pick up sight. Your ears pick up sound. Your inner ear, another component of your inner ear, registers where you are in space, like whether your head is moving, if it's upside down, if it's turned to its side, so that you can orient yourself properly against gravity. You have a sense of touch, you have pain receptors, you have some that are inside of you as well, like viscerosensory receptors that pick up things like hunger, for example, or general kind of malaise going on. Whatever it is, though, it's going to be sent to the central nervous system for integration. The central nervous system, and mostly the brain, interprets the sensory information and determines effector output. It takes in that sensory information and it identifies it for what it is, and then it decides what needs to happen about that sensory information. Sometimes it's just putting a label to it. In this image, you have a person who's looking at a glass that's filled with water. If you're not going to do anything with it, if you're not thirsty, your brain is just going to look at that information and then tell yourself that this is in fact a glass of water. It's bluish, it's otherwise clear, it's sitting on a table, that kind of thing. If you also register thirst, it'll also send out information to your skeletal muscles to reach out, pick up that glass, bring it up to your mouth, and then engage your muscles of swallowing to bring water into the body. Your motor output is what's going to activate effector organs. So you have sensory input pathways, integrators, and sensory output nervous system pathways. There's two major anatomical divisions of the nervous system, the central nervous system and the peripheral nervous system. Central nervous system can be abbreviated as CNS, peripheral as PNS. For the purposes of exams, short answer questions, I'd like for you to spell out these terms, please. The central nervous system includes only the brain and the spinal cord. This is the integrating center and control center for the nervous system. Information comes into the brain, sensory information comes into the brain, and it interprets that information, it processes it, it makes a decision, and then it sends output to somewhere in the body or somewhere else within the brain. The peripheral nervous system is everything that's not the brain and the spinal cord. This includes the regular nerves that you think of in like your arms, your fingers, your legs. It also includes spinal nerves, nerves that come straight off of the spinal cord, and cranial nerves. There's a variety of nerves that come straight off the brain and the brainstem to do things mostly within the head. Even though these structures come directly off of the central nervous system, they are not considered part of the central nervous system. Spinal and cranial nerves are peripheral nerves. The peripheral nervous system links all parts of the body to the central nervous system. So these are anatomical divisions. There's two major functional subdivisions. The peripheral nervous system has two functional subdivisions, the sensory division and the motor division. The sensory division features afferent fibers. Afferent goes towards the central nervous system. Afferent like at. These fibers go at the central nervous system. Your motor fibers are called your efferent fibers. These exit the central nervous system. Your sensory fibers and your motor fibers are all part of your peripheral nervous system, but they either bring information to the central nervous system or from the central nervous system. So you can think of your sensory division as being input and your motor as being output. The sensory division features two types of fibers, somatic sensory fibers and visceral sensory fibers. Somatic means body, and visceral refers to organs. So your somatic sensory fibers are body sensory fibers. If you touch the desk with your fingertip, you get mechanical pressure sensation that's going to be picked up from nerve endings in your skin and delivered to your brain by way of somatic sensory fibers. Joint sense, like where your body is in terms of flexion or extension, for example, and information from your skeletal muscles are also transmitted through somatic sensory fibers. Your visceral sensory fibers brings in pulses to your brain from the organs. So your stomach, for example, if it's grumbling because it's hungry, it's going to send hunger signals from itself to the brain. Efferent, motor fibers, I will typically use sensory and motor rather than afferent, but that's a general trend. Occasionally I will put in afferent or efferent just to make sure you remember what they are. So motor fibers go from the central nervous system to some kind of effector organ. It could be your skin, it could be your salivary glands, it could be your skeletal muscles, it could be your stomach, it could be anywhere. Your somatic nervous system, remember somatic means body, controls voluntary stuff. So basically your skeletal muscles. The autonomic nervous system controls involuntarily moved things in your body. So autonomic is sometimes referred to as the visceral nervous system. The autonomic is the preferred term. Two major divisions of autonomic are the sympathetic nervous system and parasympathetic nervous system. So far we have voluntary and involuntary nervous control, and then of involuntary, you've got sympathetic and parasympathetic. Sympathetic nervous system is your fight or flight stuff. You're at the zoo, the lion gets out of its not cage, you don't keep them in cages anymore, but out of its exhibit, I guess, and it starts running after you. Your body is going to go into survival mode and try to get you to run away from that lion, right? Fight or flight. You're either going to run or you need to fight something, I suppose. Parasympathetic is kind of the opposite. It's your rest and digest stuff. When you want to lay down and take a nap, when you are eating, sexual arousal falls under this category. These things are controlled by your parasympathetic nervous system. At all times, most things in your body are being influenced by both the sympathetic and the parasympathetic nervous systems. It's just a matter of how much the scales are tipped in one direction or another. So, for example, if you step on a nail, what's going to happen? You're going to pick up that information by your sensory fibers, by your sensory nerve endings. Those are going to bring information to the central nervous system by way of the peripheral nervous system. The central nervous system is going to say, oh, the tip of that nail is sharp. Don't let your foot go down anymore. Pick up your foot, get it away before you get a puncture wound. So your central nervous system has made that decision. This is bad. We don't want to do any more of this. And it's going to send information to your body to avoid that, what's probably about to happen. It'll send that information by way of peripheral nerves in the motor division. And you'll have a couple of things. Your somatic nervous system will be engaged so that you can rip your foot back away from that nail and you don't injure itself any further. And it also might stimulate your autonomic nervous system. If you are about to step on a nail and it's super dirty around there, you haven't had a tetanus shot in forever, feeling like you almost stepped on a nail might really scare you, right? And when you get scared or panicky or super nervous, your body goes into fight or flight mode. So you may tip the scales a little further in sympathetic mode, so to speak, in your body. You almost step on that nail, you freak out for a second, You start to sweat, your mouth dries up, your digestion sort of shuts down a little bit. If you're running from a lion, if you're trying to survive and run for your life, you don't really need to be spending calories digesting food. You might not live long enough to use it anyway. You're going to have a rush of blood to your skeletal muscles. So to help move your leg away from that nail faster, to run away from the bear faster. Your blood vessels close to your skin will dilate a little bit too to offload the heat generated from your faster working skeletal muscles. You might sweat a little more. Your pupils might dilate. Your sympathetic nervous system might be activated. So notice that some of these pathways are going to involve multiple components at once. You're going to almost always involve both the sensory and the motor fibers, which will deliver information by way of the peripheral nervous system to or from the central nervous system. Oftentimes, both the somatic and the autonomic nervous systems are also stimulated. You always have a little bit of both of these going on all the time with most of your body structures. But if you start to go into panicky fight or flight mode, your sympathetic nervous system is going to ramp up activity and basically outweigh parasympathetic influence so that you don't really see any of the parasympathetic stuff happen. It's going to be overshadowed by sympathetic reactions. And vice versa. Super hot celebrity flirts with you. Think of that person who you would have like the pretend pass with, right? You see them. You're in the elevator with them. You pick up their beautiful glowing face with your sensory nerves, right? Your eyes, in this case. Information about who that is, the colors that make them up, their shirt, their skin, their hair, their makeup, their whatever, how bright in that elevator it is going to be brought up through the peripheral nervous system to the central nervous system. The central nervous system is going to be going, oh, jackpot, this person's super hot. You need to talk to this person and flirt. So it's going to send out a few different signals. It's going to send out its information by way of the peripheral nervous system, specifically motor division of the peripheral nervous system. And it's going to stimulate you to talk. You want to talk to flirt with this person, or at least bat your lashes at this person, right? You're going to need to contract some muscles to do that. And so you're going to stimulate your somatic nervous system. You're also going to stimulate your autonomic nervous system. In this case, this is sort of a low degree of arousal, right? Of sexual arousal. So the parasympathetic division is all about that. If you're running from a lion, this isn't something you need, right? This stimulus isn't something that you need right in that moment. It'd be a waste of energy at that point. When you are in a restful, relaxed situation, that's when it's appropriate to digest food or take a nap, or that's when arousal would be appropriate, right? So your parasympathetic division is going to be stimulated a little bit. Your pupils will change. They'll constrict a skosh. They will, your body will send blood to the right places. I'm not going to get into too much detail. You know how that works. You also might stimulate a little bit of the sympathetic nervous system if you get nervous around this person too. But mostly, if we're just talking about like, oh, wow, here's my shot, and you're excited, you're not scared, you're not nervous, you're just excited, that's going to be overwhelmingly a parasympathetic influence. If you're driving down the road and the traffic light suddenly turns from green to red and you're about to run a red light on accident, you're gonna need to slam on the brakes, right? So that you don't hit anybody, so you don't run the red light when the cop's looking, whatever. Your eyes pick up that sensory information, send it to the CNS by way of the PNS. Same path every time, right? You're picking up input, shooting it up to the brain by way of peripheral nerves. This is always going to be the same. The output's the part that sometimes changes. The central nervous system will send that information. Oh crap, it's a red light, you better hit the brakes. through the peripheral nervous system by way of motor fibers. You'll involve your somatic nervous system to hit the brakes. And if you almost T-boned somebody in the intersection, if you hadn't hit the brakes on time, you might get scared and panicky and stimulate your sympathetic nervous system. Again, your parasympathetic is still happening. Okay, you still have parasympathetic influence on your different body structures, but in this type of a circumstance, your sympathetic will ramp up and it will dampen the effects of the parasympathetic. It's not a binary thing. You don't have all of one and none of the other. It's a matter of where the balance is.